Welcome to the Art and Science of Mead. Mead testing and analysis. Hydrometers and refractometers. Welcome to our series of educational videos dedicated to the craft of making mead. This presentation is about hydrometers and refractometers. It's more of a beginning to intermediate presentation. Those of you that have been making beer or wine or mead for some time, I'm sure are well familiar with the benefits of hydrometers and refractometers. These are tools which we use to measure how much sugar is in the unfermented must or in the finished mead. The measurements can be recorded either as specific gravity or as Brix. Knowing what these measurements are before, during, and after fermentation is essential for successful mead making. So what is the difference between these? Hydrometers can be used before, during, or after fermentation. They do require some type of other vessel, such as a graduated cylinder, to put a certain portion of the mead into, and they measure the density of the liquid. Refractometers are generally used before fermentation, as they can be inaccurate if alcohol is present, although there are spreadsheets available to correct for that. The benefit is they only require 1 or 2 drops of fluid, as compared to removing a larger portion and floating the hydrometer in it. And they measure the refractive index of light with a prism. So a hydrometer is a glass bulb with a weight that floats in the liquid being measured. It can be used before, during, or after fermentation. Some hydrometers also have a thermometer, and that's important because you need to correct for the temperature of your liquid in order to get an accurate reading. They do break easily. I recommend having more than one. You may go many years without breaking one, and then you'll break one right at a time when you need it, such as taking an important measurement right when you're making a batch, and so on and so forth. There are also different types of hydrometers, wide range and narrow range. Wide range typically goes from 0 up to 35. Narrow range is much smaller. I have a photo of one that goes from -5 to +5. I like the narrow range hydrometers because they're easier to read and therefore get a more accurate reading. So I have a whole collection of hydrometers. Refractometers are very helpful prior to fermentation, so you can adjust the must exactly before you pitch your yeast. A little bit higher or a little bit lower for exactly what you want, and because they only require a droplet or 2, they're very easy to use. Do you need to add more honey? Dilute it with some juice or water. It does need a light source. Of course, this can simply be sunlight coming through a window or perhaps a light bulb in a lamp that you point it towards. And some models have automatic temperature compensation, which is very useful because temperature will affect the reading that you get. So having ATC or automatic temperature compensation can be very helpful. And they should always be calibrated before use, typically with a distilled water and then also with a known standard that you calibrate it against. There are some higher grade or higher level gadgets that you can purchase if you want. I tend to be a little bit more old school and use the glass hydrometers and the manual refractometer, but I have many friends who have used some of the higher end ones, including the TILTTM hydrometer. The nice thing about this is it does connect to your phone or a tablet, and you can get real-time readings of specific gravity. It's accurate. The one thing is that you should not use it if there's actually fruit present, because the fruit fermenting with some carbon dioxide in it will rise and can give you a false reading for specific gravity. But in a beer or a traditional mead or a wine that's made, say, out of concentrate or juice rather than actual fruit, it can be very accurate. You can get a digital refractometer. This one's from HANNA. It also uses a small sample size, just a couple of drops, and you can save the data. It's a fast response with automatic temperature compensation. And then finally, I have friends who have the easy dens who are very happy with it. It only requires a small 2 mm sample, and it's considered to be accurate and to measure both specific gravity and then alcohol as compared with the original reading. And then it can also graph this out through the app. These do cost more money than the simple traditional glass hydrometers or the manual refractometer. So when you're first starting out, I would get the more readily available and less expensive. And then if you have some money to spend, you might consider getting one of these. So what's the difference between specific gravity and Brix? You know, when I first started out brewing, I was a beer brewer, and I basically thought about specific gravity. But then later on, my knowledge increased with winemaking, and I even took some enology courses. And now when I make mead, I only think in terms of Brix. And so someone talks to me about specific gravity, I almost in my head have to convert it over to Brix to kind of know what they're talking about, even though many years ago I would use specific gravity alone. It's sort of like looking at difference between metric system versus imperial units or whatnot. So specific gravity, it's a measure of the relative density of the liquid compared to the density of pure water. So pure distilled water has a specific gravity of 1.000. Brix is a measure of the sugar dissolved in the liquid. So 1 degree Brix is roughly equal to 1 gram of sucrose in 100 milliliters of solution. So 22 Brix is roughly 22% sugar. Pure distilled water has a Brix of 0. Now this is not exactly going to always be correct, and the reason why is you can have other dissolved solids in there. You can have other sugars than sucrose for what Brix was designed for, but it's a reasonably good estimation of sugar content. Now, if you're like me, sometimes you might need to convert back and forth between specific gravity and Brix. Maybe you're more comfortable with Brix and a friend is talking about specific gravity, so it's useful to convert back and forth. Or let's say you're reading a recipe of some kind or something and you want to kind of flip back and forth between that. There are online calculators, spreadsheets. Rule of thumb is just to divide the specific gravity, take away the 1, and then divide it by 4, and you'll roughly get what the Brix is. This is a very rough estimate, however, and it's less accurate the higher the gravity and higher the Brix is. But it's a useful rule of thumb if you just don't have the opportunity of entering it, onto an online calculator and getting a more accurate conversion. So beyond Brix, there are other scales that you might see mentioned in some of the various books or references. We typically use Brix for fruit juice, winemaking. They use it also in the sugar industry, carbonated beverages. These units tend to be used more in brewing and in Europe. Balling is used by South African wineries and a few breweries. Baume originally was represented by the percent by the mass of sodium chloride in water, but it is used in some U.S. brewing and in French winemaking. And then Oxley is a direct reading for sugar content used mainly in German-speaking countries, Germany, Switzerland, and Luxembourg. So why bother to measure specific gravity or Brix at all? I have to admit, when I first started out, I did make some batches where I didn't really even take a measurement. I just sort of, flew by the seat of my pants, and it kind of worked out. In hindsight, that was, that was definitely not good practice for mead making or beer brewing. I got away with it, but it's something I certainly don't recommend, and I would never do that now. At the very minimum, I'm getting a Brix or specific gravity right before I pitch the yeast, and then right at the end of fermentation to see, did it actually ferment to bone dry and not have any residual sugar that might start fermenting later. So by measuring gravity or Brix, you can determine the progress of fermentation. How far along is it? Is it sluggish? Is it a stuck fermentation? You can also predict how much potential alcohol might be present after fermentation. So basically, what your Brix is or gravity is starting out will give you an idea of what the potential alcohol might be, assuming that the yeast does ferment it to completely dry. You'll know when to add nutrients. Some of the staggered nutrient addition regimens recommending add nutrients at 1/3 sugar depletion, and you need to know, what your gravity or your Brix was starting out to know when that is. calculate how much alcohol is present after fermentation. So if you know what your starting gravity or Brix is, and then what your final is, there are formulas in order to convert that to what an estimation roughly of what your alcohol level is. Determine how much residual sugar is present. Sometimes when I'm making a semi-sweet or a sweet mead, I may back sweeten. I'll kind of do the math and add what I think I want to aim for based on maybe some tasting trials, but I'll still take a measurement to know, did I get there? Whether it's what I want or what I don't want, at least I'll have that measurement to know for future reference, or even right on the spot if I need to adjust a little bit further. Maybe I didn't add, and my calculation was wrong, and I need to add a little bit more honey or whatever sugar I'm back sweetening with to get it right where I want it to be, based on what tastes best. And then to know when fermentation is complete. We see online on the forums many times, I see bubbles in my airlock. Does that mean fermentation is still going on? I didn't see any bubbles in my airlock. Does that mean fermentation is complete? You can't really determine based on bubbles in the airlock, with certainty, and that's where getting a gravity reading, a Brix reading, will tell you, is there any residual sugar present, and has fermentation completed or not? So how do you use a hydrometer? Well, first you sanitize your wine thief, or if you're using a turkey baster, clean and sanitize that. Pull some of the liquid out of your carboy or your bucket or your barrel or wherever it's fermented in or being aged in, and I typically put it into a graduated 250 milliliter graduated cylinder. And then you float the hydrometer in there, and you're going to note that there is a meniscus present, and you want to read right at where it hits the bottom where the lines are. Be careful not to read where the liquid kind of climbs up the side of the graduated cylinder slightly, but at the bottom, right at the bottom of the meniscus where it crosses over on the lines on your hydrometer. If there's any bubbles, for example, it's still fermenting, you might want to tap it and spin it to try to spin off some of those bubbles, because if the bubbles are sitting on the hydrometer and there's enough of them, they may give you a falsely higher reading than you would normally get. And then record your measurement and also the temperature, because you will have to correct for the temperature depending on what these have been set at or calibrated at. So you want to take the reading with a hydrometer floating in a graduated cylinder. What you don't want to do, though, is to just stick it in the carboy. And I've seen a lot of people do that. You don't want to do it because if you imagine if it breaks in the carboy, now you've got a mess and you've got glass. And are you going to get it out? Is it filterable or being able to rack it off? Not to mention, whatever's in the thermometer has gotten into your mead. So don't do that. Pull a little bit out. Put it in the sanitized graduated cylinder, take your reading, and then you can either pour the sample back. If you sanitize that graduated cylinder, it should be fine. Or, you can take the opportunity to do a little bit of a taste testing. It's always a good idea to taste a little bit, as the fermentation process goes along, so you will learn, if it's going along according to how it should be, or if there's a problem. So you can either pour it back, or you can drink some of it or all of it if you wish. As I mentioned, it is important to adjust for temperature. Different hydrometers are set at different temperatures. They're calibrated, commonly at 20 degrees centigrade, but not always. So you always need to read the label. If it's at a higher temperature, it will float lower as compared to if it's at a lower temperature. And that's why we need to use temperature correction. There are calculators online for correcting the readings based on temperature, and I strongly recommend that you use them and just enter the temperature that your hydrometer has been calibrated at, and then the actual temperature, and then whatever reading you got, and it will correct for that and give you a more accurate result. Hydrometers should come from the factory already calibrated, but I've had a few that were off, so I never trust a new hydrometer until I've calibrated it to be sure. So you float the hydrometer in distilled water, ideally at the temperature that it was designed to be used at, and it should give you a result of 1.00 for gravity or 0 for Brix. Well, let's talk about refractometers. Before every use, it's good practice to calibrate your refractometer it could be knocked or shaken and get a little bit out, and there is a little screw on the back of most of these that you can use to calibrate. So if you have a refractometer that goes down to 0, you can actually zero it in using distilled water. Some refractometers, such as the ones that we use as beekeepers for assessing the moisture content of honey, does not go down to 0, so you'll have to use a different standard solution for those. And it's always good to calibrate with a second time with another known standard, so that you can be sure between both of those that they're accurate. And if they disagree greatly, then you've got some problems. I mean, maybe you need to get a new refractometer. So to use, place 1 or 2 drops on the prism, and when you put the little flip back down the little plastic top, make sure that it equally distributes on the glass. Hold it up towards the light. Could be sunlight outside, towards a window, or it could be a light shining from a light, in your house or a lamp. And then use the eyepiece to focus if necessary. And then take your reading. And that's going to be basically the line where it crosses. And then afterwards, of course, clean and dry. Now, typically, you cannot use a refractometer accurately once alcohol is present, and that's why we usually use them before fermentation. There are spreadsheets that have been created to correct for this, and there's a few links there where you can look them up. Myself, I've used these, and I took an accurate measurement using a hydrometer versus a refractometer reading that was corrected. I find that they did not always agree, so I always hesitate to use a corrected reading using a spreadsheet. But some people swear by them and say they're just accurate enough, and so I'm not going to tell you what to do. I recommend you check these out, maybe compare it to an actual hydrometer reading to see if there's a big difference, or maybe not enough of a difference to be meaningful. How to estimate alcohol content. So you can use the hydrometer reading or refractometer reading, the original before fermentation, and then the one taken at the end of fermentation, to get a reasonable estimate. And I want to be very clear, this is an estimate. If you want to get a very accurate measurement of alcohol, you'll probably have to use some other techniques, such as ebulometry or distilled spirits and some of these other methods. I'm not going to go into them in this presentation, but I plan on having another presentation for how to directly measure alcohol rather than estimating it, as most of us do, based on your initial gravity Brix versus the final. So there are spreadsheets available, and there are also some formulas. They're fairly simple. I tend to enter my data into an app or an online calculator. This one is FermCalc. It's freely available. I really like it. And as you'll notice here, there's some different readings depending on the methodology. So the readings can, range all the way from 11.5 estimated alcohol, to 12.8% alcohol. That's a huge difference. These are basically a ballpark estimate, good enough, especially for us home mead makers. If someone's a commercial mead maker and they're close to a cutoff for the taxes as per the TTB, they have to be very accurate, and they could get into trouble if they had it out, to a higher tax category and they did not pay taxes and it was found out by the feds. And so they may actually have to send their samples off to a certified lab to measure it, with a technique that's much more reliable to measure the actual alcohol. After fermentation has been complete, you can estimate what the alcohol is, assuming that you've taken an original gravity or Brix reading prior to fermentation, and you can use one of these calculators, such as this one from FermCalc, where you enter the original reading prior to fermentation with what the final value was after fermentation. On this site, they also offer the ability to compare a after fermentation refractometer reading with an after fermentation hydrometer reading to give you an estimated alcohol content. It's an interesting calculator. I've played around with it, but I find that it's not quite as accurate as the determining the alcohol based on spirit indication, ebulometry, or even just using the before and after gravity readings to do the calculation. But it's nice to have tools like this available to us, and I recommend you check these out to see if it'll work for you or not. So how do you know when fermentation is complete? Well, before bottling, you need to make sure that fermentation is complete, because if you don't, you might get bottle bombs later on. Anyone who's brewed, made wine or mead long enough will have an experience where there are bottles in their closet or basement popping the corks out or simply exploding, and that's something you never want to replicate. So presence of bubbles in your airlock does not mean it's still fermenting. There could be some dissolved carbon dioxide that's sort of off-gassing with changes in the environmental air pressure. And the absence of bubbles doesn't mean that the mead is done fermenting. It might have gotten stuck or is very sluggish. There's still some residual sugar present. You put it in a bottle, and if you don't stabilize with sulfites and sorbate, you could be in for a surprise weeks or months later. So by measuring your gravity or Brix every few days, you know if the fermentation is coming to an end and completing fermentation of whatever sugar was present. On the other hand, if you're measuring gravity and Brix, every few days, you can know that it's starting to get stuck. It's not completing fermentation. And if you take action early enough, you might be able to get it unstuck. You might be able to restart it without it being that of a big deal. It's much better to do that early on as it starts getting slow compared to much later when it's completely stuck and it may be much harder to get it restarted. So in general, when it's fermented complete dryness, the gravity is going to usually be less than 1 and the Brix is going to be less than 0. There are some exceptions. If you have a lot of other dissolved solids in there, or if you have other sort of unfermentable sugars, that can give you a reading that seems higher than you would expect, even though it is completely fermented. And if it's higher than that, you really have two choices. You can just wait until fermentation finally completes itself, or you could leave it as is, like an off-dry or a semi-sweet mead, and just stabilize it with sulfite and sorbate before bottling to make absolutely sure that it's not going to start fermenting in the bottle. So that brings us to the end of this presentation, hydrometers and refractometers. Like I said, this is sort of an introductory to intermediate presentation. It's those of you that have fermented alcohol for years are well familiar with the benefits of hydrometers and refractometers. I tell new mead makers, a hydrometer is one of the first tools you want to get. You first, obviously, a bucket or carboy to ferment in, and I guess maybe a spoon to stir the honey and dissolve it. But after that, the next tool that you should get when making mead is at the minimum a hydrometer. They're indispensable for preparing the must, to follow the progress of fermentation, estimating how much alcohol you might have, and then knowing when fermentation is complete and you're ready to bottle. You can use hydrometers before, during, or after fermentation. Refractometers we typically use before alcohol is present, but there is a little asterisk, and that is you can correct for that alcohol using a spreadsheet. I've had variable success with that, so I simply tend not to do that, but I know many say they have wonderful success and it works just fine. So if you're going to use the refractometer and measure after alcohol is present, I recommend that you compare it to what your hydrometer is saying to see if it is close to where the value is or not. Remember to always correct for temperature. The readings can be quite different if the liquid is warmer or colder than where the hydrometer was calibrated for. CO2 and other solids can affect hydrometer readings, so if there's a lot of bubbles, they can float that hydrometer higher than it would be. So tap it or spin it to get the bubbles off, and then read it quickly before those bubbles reaccumulate. This is more of a problem in an actively fermenting sample. Alcohol can affect the refractometer readings. Again, there's spreadsheets, but use them if you would like. And then remember to calibrate your refractometer. Thank you for watching this short presentation. I hope that you find it helpful, and I hope that you find all of the other presentations within this series, The Art and Science of Making Mead, to be helpful in your pursuit of making the best mead possible.